Drummond, may I ask you a very basic question? Uh,
Sure, Ajay.
what is digital trust? And we all understand trust and we have used it in all kinds of relationships, scenarios, networks, right? But what is digital trust and how different is it from the trust that we use or we have used so far?
Uh, it's a critically important issue, actually. So we all know how we establish trust in the real world, and it's not necessarily always easy in the real world, as we know, right? There are, all kinds of scams and situations where folks are taking advantage of our trust. But in the digital world, it is frankly much easier to abuse trust, to use the distance to send all the kinds of trust signals that we get in the real world, where we can look people eye to eye, or we can go to a physical a storefront, a bank, a location. Those are very hard to spoof or trick someone. Online, it's trivially easy. You can copy a website or a web page. You can actually now, bots can do that in less than a second. So it's much easier to fool someone, send all those signals, especially, average users of the internet. They're not savvy about all these different ways that they can be attacked. And as a result, establishing online trust is actually becoming progressively harder as the digital infrastructure we've created is being exploited by more and more attackers. Some of them now, as we know, unfortunately, organized crime. It's become a major aspect of their business. And nation states. We're reading, right now, at least here in the US, about attacks being made on our election system. And they happen because people can't tell the difference between an email from someone they trust and an email that happened to be sent from, a foreign adversary.
Thank you, Raman. So is it fair to say that, in the real world, most of the time the trust was established between known parties. So know you and we have a relationship, so I can trust where you're coming from, what you need, what to expect. But in the digital world, increasingly, we are not aware, like you said, the email may be coming from an adversary. We are not aware of the other endpoint. And it may be that, there is no one single endpoint in a digital interaction. Many actors might come together dynamically. So even if we want to know, we may not know. So it makes the problem more challenging. What do you think?
Much more challenging. I love, I think it was Craig Burton who said, on the internet, everyone is 0 degrees from everyone else, right? You can connect, you could be on the other side of the world and we could be having this conversation. In fact, we are in different states in the United States right now. So when you have that capability, you don't have the ability to do what we do in the real world, to establish trust via all those other signals and knowledge. And yet part of the richness of the internet is that we can have those many new relationships. You can have markets that are serving, hundreds of millions or billions of people. So it makes the need for how do you establish trust online and what intermediaries and infrastructure used to do that very important, especially now that we're all being isolated because of COVID.
So given the difference between the real world and the digital world, I'm sure our trust models have adopted and evolved over a period of time. May I present, my understanding of this evolution and get your perspective and see if, digital trust has caught up with the complexities you described?
That sounds great. Yeah.
Like we all agree that trust is the foundation on which every interaction, every transaction is built. From the very first exchange using barter to e-commerce, we exchange value on a foundation of trust, right? So let's look at the evolution. In the past, it used to be in-person ceremonies, right? So whether it's a notary or it's the grocer or it is, a personal relationship with someone, right? We have used everything from signature to wax seals, right? To convey that, we stand by this agreement, or this transaction is underwritten here, right? So, we have become used to trusting a paper-based credential, whether it is the passport or a driver's license or a medical certificate, etc. Right? So this was before the internet era. And then when it came to internet, we started to have these internet accounts. So we extended the model of trust, which is lock and key. So we put a lock on our door. So we said, our account is our home and a lock is a password, right? So we extended the model, and then, this grew very quickly as services and applications became available, right? This led to multiple accounts, multiple services that we wanted to use. And then remembering accounts, passwords for each account became a challenge. And the trust world moved up and said, hey, you could use a single sign-on platform. And in the social world, Facebook, Twitter, became the SSO platforms. Google became the SSO platform. But one of the things that I worry about is that now suddenly this platform has become privy to any interaction I'm doing. They were not involved so far. I'm actually interacting with a completely third party. But because I've used Twitter to log in, or I've used Facebook to sign in, willy-nilly I have made them a party to this interaction, right? So, moving forward, we worry about how do we connect? Who do we connect with? Because there is this plurality of services and endpoints. It is hard to define the network boundaries, right? So we have used this lock and key, castle and moat model of security, of privacy, to ensure that outsiders stay outside and insiders are safe. But there is this paradox there, because insiders want to access now these SaaS services, software as a service, which may be sitting outside my perimeter. Or under COVID situation, I may want to access what's inside from home, which is outside, right? So this inside-outside model is not working because the network boundaries are blurred, right? There is no wall to raise. There is no more, trenches to dig deeper into, right? So the question I have is, do you think we have kept up with the digital world? Has digital trust model, have they evolved to keep up with the digital world?
You want a one-word answer? No, that is precisely the very, very large trust gap that we face, and that we are, striving very, very hard to build the infrastructure to fill.
So we know that physical trust, that in-person trust works really well in the physical world, and in digital world, digital models, trust models haven't kept up for all these reasons. But Elizabeth's question about network boundaries is a great question, and I want to illustrate, what happens, or what I mean, or what we mean in general about trust boundaries. So imagine we pick a product like Zoom we are using, which says end-to-end encrypted, or we use WhatsApp and say this is end-to-end encrypted. Now imagine I share a picture with Drummond and say, Drummond, this is for your eyes only. Okay. So I send the picture using WhatsApp. It gets to Drummond in an encrypted manner. So WhatsApp has encrypted it and carried forward. And when it hits Drummond's WhatsApp client on his mobile phone, it gets decrypted and it is presented. But simultaneously, it gets stored in a database on Drummond's phone. So if it is stored on the phone, that is outside the network boundary of WhatsApp. So WhatsApp network starts with the client and ends with the client, and we're assuming that using various technology, the in transit is also in control of them. But the moment it hits the phone, they lose control because they can't control the phone. So it will get that image, that picture will get backed up to Google Drive or iCloud, and even if WhatsApp wants to enforce my policy, which is it is for Drummond's eyes, cannot be enforced. Granted that the picture is encrypted, but WhatsApp has no control. It has gone beyond the network boundary. We see this in the context of an enterprise. This diagram on the right shows that enterprise is fragmented in terms of a network, right? From supply chain to operations to sales and so on, right? Everything is its own world. These are silos. So you may have cross-domain visibility, but what you can share across is governed. The policy is governed by different authorities, right? So there is no way for me to share data and assume that my policies will be governed in the next network domain. So data and policy, they don't travel together. That's the fundamental problem. So as it travels across network boundaries, I lose control, I lose policy control. Policy control such as, is it for your eyes only, right? Can you share it with others? What happens if I change synchronization? Under what circumstances can you use it? What will you use it for? Those are the types of policies you wish to control, but you lose control the moment it goes beyond your domain, right? I want to ask Drummond about his views on this trade-off we make. So we know that some of our data is being used without our explicit consent. So for example, we search something on Google, and Google provides these search results, but it has learned something about our interest, right? It knows something about our location, our state, our presence, which device we are using, where are we coming in from, right? The server knows, Google knows, and they leverage, they monetize that data differently, right? So we know that, but it is very convenient. So I'm taking a real world example from this last few weeks where Amazon has launched a new payment system. They didn't own a device, a mobile device. So Google Pay, Apple Pay were participating in every transaction. And of course, Amazon wants a piece of that. So they come up with this idea that can we oversimplify accepting payments for retailers? So they've come up with this platform called Amazon One that retailers can integrate so that Amazon can get a piece of every transaction. So the way it works is that you put your palm on a scanner and it does an IR scan, not just of the palm surface, but what's underneath, the ridges, the veins, the patterns, right? It encrypts that image, sends it to the cloud, extracts a unique signature, and now every time this happens, they can identify that this is Ajay or Elizabeth or Martha, right? Now contrast this with how Apple Pay works. So I could use Touch ID or Face ID. They extract the signature but store it locally. So when I go and assert that I want to use Apple Pay, there is nothing which is on the Apple cloud, right? I control the card I want to use. My biometrics are local on this machine. So if there's a subpoena from a surveillance agency, Apple can say, look, I don't know. And they've said that in the past. But what happens with Amazon's Amazon One is that the biometric is sent to the cloud, the signature is extracted in the cloud, and it is now sitting there. So if there is a subpoena, and says, whose palm is this? They will say, this is Ajay's palm. Or can you give me Drummond's palm? Here it is, right? So this trade-off, it's very convenient what Amazon is suggesting. But, is it trustworthy? Can we believe that, this will not be misused and not become an instrument of surveillance? What are your thoughts?
Ajay, this is a really good question about privacy by design. What you showed with Amazon, where all the data is going to the cloud, it forces trust in that cloud provider, and in order to do their job, they have to have visibility on that data. So you've got you have one example of a trusted intermediary where you have to have that reliance. Whereas what Apple's done, when the information is local on your device, you're still trusting Apple as a provider of the hardware and software that information is kept on your device. They're not leaking it, but you're not having to trust a cloud provider, provided Apple's done that, and the device actually can be inspected and certified to make sure that that it's behaving that way. To me, that's a perfect illustration where you can do privacy by design, and you can say we don't need an intermediary there, and the whole system is safer for that reason. I'm a big believer in applying privacy design at progressively larger and larger scales, and that's a perfect example.
So in this context, Apple becomes the intermediary, and we can trust it because even if somebody puts a gun to Mr. Cook's head, he cannot share our data. Okay, so I'm going to share my screen to ask you if it represents the properties, the characteristics that we would expect from a digital trusted intermediary, right? I'm going to share my screen. This is really your slide, so please go ahead and talk through this. The next few slides are yours.
So what we're seeing here is I think a wonderful example I just shown there, where when you're using that trusted intermediary and all the parties are reliant on it, that's the model we have today. That's what you see. Amazon one, just as we rely on Amazon as a central intermediary for everything that Amazon provides. That's the model that they've provided, or they're proposing with Amazon One for payment. And it's interesting because these are these three things, right? We expect to make it, they make it simpler, they make it easier. That's Amazon's whole, rationale for business. They use intelligence to do that. They are adding the smarts, and ideally that means less and less data is needed. Although to the extent that that's concentrated in the cloud, that, as I said, can become a privacy issue. But we also expect them then to secure that each of those arrows into the intermediary is secure, that the clients are secure, that the data will remain secure. These are all the things that we are looking for the intermediary role to take care of. And it's a lot, it's a high burden.
So would it be fair to say that if, a hash key was generated locally at the Palm reader from my Palm image, and what is stored is an encrypted, I can hash into it anytime, I want to compare it with the new image, that would be a better system than extracting the image, extracting the signature in the cloud and storing the key in the cloud.
Absolutely. The way I like to put that is, the greater the power and the security at the edge, and those three nodes that are communicating, right down to, of course, having their encryption keys encrypting that data, the less trust you have to have in the intermediary, and the more it equals out the power sharing on the platform. But that actually equals stronger security and stronger privacy. So the only one that doesn't win there is the intermediary, if they're trying to, again, monetize that data or use the power of what can become a monopoly position.
Thank you. In the past, we have used credentials, and you are working now on this new model, which actually abstracts how we use credentials and addresses the gaps we had and creates a new opportunity for a trust model to be universal. May I request you to talk about it a little bit? We have a whole section coming up for that, but just to give people an overview.
Yeah, very briefly, this is when I use my prop, Ajay. I get out my wallet and I go, we do have a simple universal way that we have evolved to establish trust in the real world, that all of us use most every day, a little bit less now that we're not doing as much traveling right now. But certainly every business trip someone takes is a good example. We use credentials that have been issued to us, from providers that we have a trust relationship with. We call those the issuers. We hold them, we hold the physical credentials in a physical wallet, but the digital version we will hold in a digital wallet. And then we present them to verifiers. And you have several really good examples here, Ajay. Classic one, when we need to prove we're over legal drinking age on the left. The issuer of that credential, in this case, it might be a government ID. I'm the holder, and the bar or the wine room in this case, if they trust that credential and they do their own verification, they look at, is that a real driver's license? Then yes, that's how I prove it, and that's how I can get my glass of wine. I think you have another example here. We do this every day with credit cards. Again, they've been issued. In that case, the issuer is a bank or a credit union, and Mary here is the holder. She's entered into one legal relationship there as a card holder, and then she presents that card to a verifier who's also in a legal relationship with the issuer and the network to comply by that agreement. And everyone's got protections and rights, and this course has dramatically simplified how we do payments.
So in this world, you have a three-party triangulation. There is the issuer, which is the source of credentials, like a DMV or a university issuing transcripts, right? And then you have the holder, the person who gets to receive these credentials, these certificates, these proofs, right? And then you have the verifier who wants to authenticate, one, that the credential is, who wants to verify that the credential is accurate, is authentic, and two, it is issued to the person who is claiming is the holder, right? So you briefly talked about the governance framework. So how does a governance framework, enable, this trust between peers? Because they're not connected using any physical integration or any digital integration. How is this done in your model?
That's what makes the basic trust triangle, the issuer, holder, verifier trust triangle, scalable. Is this role of the governance framework, which is primarily it's a legal and a policy construct, and a wonderful example of how it works to scale is in fact the credit card networks. The verifiers, of which there are in the high hundreds of thousands around the world of actually on the merchant side, I think it's 4 million plus merchants on the MasterCard network today, as an example. They do not know all the issuers of the credentials. What the governance framework allows them to do is to say, okay, but once I become a MasterCard, as a verifier, accept a MasterCard credential, I have the trust in the governance framework, and the MasterCard network, they actually vet all the issuers, and they ensure that the legal agreements are sound, that the network is secure. So the governance framework is what then allows, hundreds of thousands of financial institutions to issue those credentials, millions of verifiers to accept them from literally billions of cardholders, and the whole thing scales, even though every single transaction is actually an instance of this little trust triangle.
Got it. So, Drummond, thank you for providing this overview. And I remember last quarter, MediaX had this series on wicked problems and thinking tools for wicked problems. And one of the wicked problems we looked at was return back to campus safely, right? And I had thought about a framework. I sent it to you, and then you pointed me to Trust over IP and invited me there. So may I request you to talk about, how Trust over IP provides a framework for digital trust, where this infrastructure becomes the trusted intermediary, and it enables interoperability across trust boundaries, across ecosystems. So I've got the next few slides lined up for you. So may I request you to
Sure.
Trust over IP? Thank you.
And I want to make sure that, Ajay, you have plenty of time for the actual example that I think is very easy to follow once I explain this. So we'll do this relatively quickly. So there are, to build this digital trust infrastructure that we've been talking about, we are standardizing it. There are a series of standards coming from W3C. One of them, the first one, you see the decentralized identifiers. I'm a co-editor of that specification. And the other key one on the right side is called verifiable credentials. That's actually been a standard at the W3C, a full standard for over a year now. So these two things come together into this thing we call the Trustworthy Stack. It's a stack of protocols for interoperable digital trust, and that's the piece in the center. Go ahead, Ajay, and we'll just step through what that looks like. So that trust triangle that we just talked about, you see it right here, sort of flattened out. The issuer, holder, and verifier. This is actually a version of a picture from the verifiable credentials specification that says all digital credentials can follow this model, and they've standardized the basic format of the credential and the signatures. And the piece in the center, you see the verifiable data registry. That's the key to being able to do this at scale in a decentralized way. And the early candidates there are all blockchains. There's functioning now infrastructure that's blockchain based. The Sovereign Network, SOVRIN, is one example. But as we're developing the infrastructure, many other options are becoming available there. All different types of blockchains, distributed systems. What they allow it to do is the digital signatures that need to be applied to those credentials can be verified very widely. So you'll have things every bit as scalable as, for instance, the Visa or MasterCard networks for credit cards, but now applied to any type of credential, from any issuer, any set of holders, yeah. So on the left here, you see what we call a trust framework or a governance framework. Can now be designed, and basically it specifies all of the requirements and policies for what you're seeing on the right side there. Basically, what issuers can issue what credentials under what policies, and then such that the holders and the verifiers all know what they can rely on. What you're seeing here on the left side, anytime a verifier needs to have that information, rather than asking you for a username and password, which of course you have to know and keep track of and everything else, instead they're basically making what's called a query for a verifiable presentation from your digital wallet. And the beautiful thing is, from a user experience standpoint, all you see is a request saying, hey, this entity, which your wallet and your agent can verify, it's really them asking for this information. Do you want to give it to them or not? And it will contain everything you're seeing on the left here. And when you turn around and say, yes, it's that step one at the top, the requesting of the proof, your wallet, if you say yes, will generate that proof and return it to them. The verifier will then look inside of it, take the information, be able to talk to the verifiable data registry to verify that information cryptographically. And now they know, yep, that is just like having verified the information in a real physical credential, except with, frankly, a much higher degree of certainty, because it's much, much harder to break. So that's the basic idea of what we're putting in place. And what we're doing, Ajay, with Trust over IP Foundation, is we're standardizing that, and we're trying to turn it into, a universal infrastructure. We have over 125 companies there, of which Reboot Digital, I'm happy to say, is one. And it's gaining a lot of momentum.
Thank you. So how does this framework, quickly, if you can explain, becomes the trusted intermediary, as different from what we have seen in the past? Is it the governance framework, the standardized policy, like I said, common markup, common transport, common presentation? Is it, something like that?
Yes. On the left, you've got, the centralized role where the intermediary is really, the gateway through which everything has to go. And it works, but it has those downsides we talked about earlier. With the Trust over IP framework, we're decentralizing digital trust. We're saying you can have any number of peers, and they can take all those roles. They can be an issuer, they can be a holder, they can be a verifier for all different types of credentials. And each governance framework that says, hey, for this trust community, this is what we need, we will see tens of thousands of those governance frameworks, and they can all decide how trust can now work across those boundaries. If I have an educational credential issued by a university, Can I use it for a discount at a merchant? That's the merchant's decision, but they will know, yes, it really is, for instance, a Stanford student ID credential. And that can work for government credentials and financial industry credentials and travel credentials. So it's very, very robust, but the intermediary becomes the infrastructure rather than centralizing it in, frankly, very, very large tech companies.
Can we use the same trust model that you explained in this context to provide access to public areas, whether it is a lecture hall or a dining hall, right? Leveraging, an interoperable trust credential, okay? So this use case, is inspired by Trust over IP and the COVID Credentials Initiative, which has also grown very nicely, which uses the Trust over IP framework, right? So imagine that, Stanford or a university or a school decides that, hey, we want to bring people back in, but they must assert that they were recently, and that recently could be yesterday or 2 days ago, they were tested negative using a PCR test, okay? And that is the minimal requirement to grant access to a public area. The proof could be that please prove that you are a student, that you are registered in that class, so all of those policies can be encrypted in a QR code, which means, when I dereference the QR code, I understand what the verifier requires of me as proofs, right? So now imagine the situation where students are coming back, they're told that they have to participate in frequent testing, they show up at the lab, and now they scan this code because lab is asking for a proof. Please tell me that you're a registered student and that you've been asked that you're enrolled and give me your identity proof that you are who you are claiming to be. And it goes, these screens are directional. They show that common presentation, how a verifier is asking for a proof and how the proof is being submitted, right? So now the student goes in for the test. The technician at the lab says, hey, we want to issue the certificate to you and only to you. So please generate a QR code as a test label. We don't want to handwrite it. Only you can generate the test label because you have delegated your identity to your phone. So the QR code that the phone generates is digitally signed by you. It uses your private key and will use our public key. So now give me that test label as a QR code that I'll put on the test, right? So the test is done, the results are verified, and a certificate of that this student is not infected, the results are negative, is issued by a doctor. And that certificate is cryptographically encrypted. It is stored in that verifiable data registry that you talked about. And the student stores it in their digital wallet. In this context, the mobile wallet, right? So they store it there. So now when they show up, at a lecture hall, they scan the QR code. It asks for this proof that, you are a student and, show that you are negative and this was tested recently, right? Those proofs are asked and the student asserts those proofs using the mobile wallet and they're granted entry or, denied entry based on this. So I thought this illustrates the workings of trust over IP framework in a manner where it is similar to using contactless payments, that just like we don't think twice about it, we take a credit card, we bring it on board into our mobile wallet, we go to our grocer, we authenticate ourselves using Face ID, Touch ID, password, and now we assert, that credential, which is that the grocer says, yes, I accept your payment, and it's done.